Naimbag nga aldaw yung amin. Good day, our dear students. I am your teacher, MJ, all the way from the province where culture and technology meet, Ilocos Norte. Together, we will explore, discover, and enjoy life through Science 8. Are you excited? So am I. So buckle up as we take off to another fun-filled learning episode. This is DepEd TV. What did you observe in the videos? What made those movements possible? Great! Simply by applying force. And that's what we are going to talk about this week. At the end of our discussion, you're expected to learn the relationship between the amount of force applied and the mass of the object to the amount of change in the object's motion. But before we start today's discussion, let's have a quick drill to test how far you know about forces. I'll be showing you some images, then you tell me if there is a force applied. Let's start with this first image. Is there a force applied? If your answer is yes, you deserve a big hand. Force is applied when you need dough. Please focus on this next image. Is force present there? Great! The correct answer is yes. When you pull an object, you are using a force. You have now two correct answers. Let's now proceed to the third drill. Do you think there's a force applied? Yes, there is. Force is applied when you do weaving. And now for the last image. What do you think? Is there a force? Kinda tough one. Probably some of you would answer no. If that is so, then you might need to know more about today's topic. But the correct answer is yes. Force is still present even if an object is not in motion. Why? You'll find out throughout our discussion. In your previous grade level, you learned about displacement, velocity, and acceleration. Displacement is the gap between the initial position and the final position of an object. Velocity is the speed at which something moves in one direction. And acceleration is the time rate of change of the velocity of an object, used to describe motion as these take place with the presence of force. Earlier, I've shown you videos and we said that in order to do those activities, we need to apply force, and that is true. Let's take these as a prelude to our definition of force. Let's take as an example a door which is closed. The door will remain closed unless a force acts on it. If you want to open the door, you have to apply force in any way you want to. You can push, you can also pull. What about in playing soccer? Of course, you have to be strong enough to kick the ball towards your teammate until you reach your goal. In playing soccer, kicking a ball requires force and you must be good enough to control the force you apply depending on how fast you want the ball to move. As we said, velocity is the rate of speed of an object, and that speed depends on the amount of force applied. The stronger you kick, the faster the ball moves and vice versa. At this point, let's now define force. Force is generally defined as the push and pull applied to an object. It is also defined as an influence that changes the motion of an object. Most of the motions or movements we often see or do every day are caused primarily by force. For better understanding, let's do some experiment. I have here a table and a toy car. I'm going to put the toy car on top of the table. Look closely. Do you see any movement? Obviously, none. But how can we make the toy car move? The force applied by pushing or pulling will make the toy car move. What will happen if I push the toy car to the right? The toy car will move in the same direction as the force. Now, how do we stop the toy car from moving? We have to apply a force which is opposite to the direction where it is going. You have observed that the toy car moves once you push or pull it. This is because of the force applied on the object. The toy car on top of the table will not move unless you apply force to it. If we push the toy car, it accelerates or moves on the surface of the table to the same direction of the force you applied. If we give an additional push to the moving toy car in the same direction where it is moving, it goes faster. Meanwhile, if we push the toy car in the other side instead, opposite to the direction of its motion, the ball may slow and eventually stop. In the previous activity, we can conclude that force can make the toy car or any object accelerate or stop. But the question is, does force always affect an object to move? To answer that, let's examine this one. This shows how force acts on the toy car that causes it to move. To better understand this, let's be familiar with these terms: magnitude, direction, point of application, and line of action. Magnitude refers to how strong the force is. Take a look at this. If you push the garbage cart with a strong force, the garbage cart will move fast on the line of action because the amount of force or the magnitude affects its velocity or movement. Same is true if you gently push the garbage cart. It will move slowly. Hence, the greater the magnitude, the faster the velocity. The magnitude of a force is expressed in various ways. First is in Newton, for the MKS or the meter kilogram second system. It is also expressed in dyne, for the CGS or the centimeter gram second system, and pound for the FPS or the foot pound second system. In the International System of Units, it is commonly expressed in Newton, named after a famous physicist and mathematician, Sir Isaac Newton. On the other hand, direction refers to the points to where the object goes. Meanwhile, the point of application is the location where the force is applied. And lastly, the line of action is the straight line passing through the point of application and is parallel to the direction of the force. Now that we have already defined and understood force, then that's a great springboard to what we are going to talk about next, the types of force. There are two types of force: contact forces and non-contact forces. Let us begin with the contact forces. When we say contact forces, these are forces wherein an object needs physical contact to another object. Examples of contact forces are applied, friction, normal, and tension. When we say applied force, we are referring to the force exerted by a person or an object towards another person or object. We use F as the symbol for applied force, and depending on who or what applies the force, we write it smaller next to the letter F. Take a look at these examples. Applied force of a girl in pulling a table. Applied force of a ball towards a can. And applied force of a boy pushing a car. Which of the following pictures does not show presence of applied force? That's right. No force is applied in this picture. Another example of a contact force is friction, meaning two forces go against each other in a sense that other force go to the direction of the force being applied. This causes the movement of an object to slow down. We use F of F as the written symbol of friction force. And the other force is written as F with the object applying force written smaller right next to it. Which of the following pictures does not show friction force? That's great! Friction force is not present in a hanging chandelier. Can you follow? That's great! Let's keep going. Another example of a contact force is normal force. When we say normal force, it is the force that acts perpendicular to an object. We use F of N as a symbol for the normal force. Let's take for example a box on top of the table. In this illustration, gravity plays a role. Let's say for example the box has a mass of 1,000 grams. The box is being pulled by gravity towards the earth. As the box rests on the surface of the table, the surface is also exerting an upward force on the box. We call that upward force the normal force. Which of the following pictures does not show normal force? Very good! A flying bird is not in contact with a surface that would exert an upward force. You're doing great so far! What do we mean when we say tension force? Tension is the force applied to a string, rope, chain, cable, and the like. We use T as the symbol for tension force. If the normal force supports an object as surface resists compression, the tension force resists force that causes objects to stretch. Let's take as example when we hang a box using a rope. The rope applies force to the box, which makes it resist being stretched out. This results to tension. Which of the following pictures does not show tension force? That is awesome! Pushing a wall shows applied force and not tension force. Whoa! What a day! I hope that you had a great time and learned so much today. This is Teacher MJ. Together, let us explore, discover, and enjoy life through science. This is DepEd TV.